In the early 2000s, bedrooms across the world glowed with the hum of custom-built PCs. If you were deep into Half-Life 2 or Counter-Strike, chances are you knew the crown jewel of every setup, NVIDIA's GPU. These graphic processing units weren't just hardware, they were badges of honor. Teenagers flaunted glowing, transparent towers outfitted with NVIDIA chips like trophies of digital warfare. But beneath the buzz of multiplayer matches and pixel-perfect graphics, something extraordinary was brewing, a quiet revolution in artificial intelligence. As the years progressed, what gamers didn't realize was that these same NVIDIA chips were laying the groundwork for a technological explosion. Sometimes, the seeds of disruption are planted in the least expected fields, said Jensen Huang, co-founder and CEO of NVIDIA. Huang wasn't content with success in the gaming market. He envisioned a world where GPUs could do far more, not just render frames, but process the future. His decision to support academic research, even when it didn't make commercial sense, proved pivotal. Huang's long-term bet turned NVIDIA from a gaming brand into a cornerstone of modern AI infrastructure, now powering tools like ChatGPT and generative AI platforms around the world. Think of a GPU like a hyper-efficient brain. While CPUs are like strong solo runners, GPUs are relay teams, able to process thousands of data points simultaneously. This is exactly the kind of power machine learning needs to function. NVIDIA's chips became the backbone of everything from AI development to scientific simulations, cloud computing, and autonomous vehicles. What started as a tool for gamers became the processing powerhouse behind the digital age. NVIDIA's story is a vivid reminder, sometimes, a company's greatest impact lies beyond its original purpose. But that raises a compelling question: what if every tool we use today holds a deeper potential we're not yet seeing? What if your smartphone, your camera, your laptop, are already shaping the next wave of innovation without you realizing it? Jensen Huang's journey challenges us to think deeper about technology, not as static devices, but as dynamic gateways to transformation and progress. His relentless belief in innovation, even when it wasn't profitable, teaches us something rare in business: vision matters more than immediacy. So, whether you're a founder, a futurist, or simply someone curious about the tech shaping our lives, don't just use innovation. Question it. Stretch it. Rethink it. NVIDIA's story shows that progress often hides in plain sight, waiting for someone bold enough to chase it. Great companies don't just respond to trends, they create them, as Huang once said. If this story sparked something in you, like, share, and subscribe to join a growing community exploring the frontiers of technology and possibility. About the author. Stephen Witt is a journalist and author known for exploring how technological innovation reshapes entire industries and affects society at large. His acclaimed book How Music Got Free investigates the collision between digital technology, music piracy, and the transformation of the music business. Witt's insightful reporting has also appeared in top-tier publications including The New Yorker, The New York Times, and Wired, where he continues to examine the forces driving the modern tech landscape. Key Takeaway 1. From Kentucky dorms to Silicon Valley, the unlikely rise of Jensen Huang. Imagine being 10 years old, dropped into a foreign land, sleeping alone in a cold dorm room in rural Kentucky, without your parents, and without understanding the language. That was Jensen Huang's reality in 1973. Sent from Thailand to the US to escape political unrest, Huang found himself at Oneida Baptist Institute, a rough-around-the-edges boarding school his father mistakenly believed was elite. Instead of privilege, Huang encountered isolation, racism, and relentless bullying. But this would become the crucible that forged one of the most resilient minds in the tech world. As the only Asian student in a sea of unfamiliar faces, Huang was both a target and a standout. His limited English and exceptional intellect set him apart in uncomfortable ways. Yet even in adversity, he adapted. "I pretended to be a martial arts expert," Huang later admitted, not out of arrogance, but as a defense mechanism. His unrelenting grit and quiet courage allowed him to survive, even thrive, in an environment meant to break spirits. As Aristotle once said, "It is during our darkest moments that we must focus to see the light." When Huang eventually reunited with his family in Oregon, everything changed. He found his tribe among fellow math nerds and the quirky members of a local computer club. Obsessed with the Apple II, he began programming and developing the mental muscle that would later build NVIDIA's revolutionary GPU technology. It wasn't just computers, he took up table tennis with equal fervor, earning national ranking within a year. Like the circuits he would later design, Huang's mind was built for pattern recognition and precision. What drives someone to turn every obstacle into a stepping stone? Why does one student see a fight as trauma, while another sees it as training? Huang's story forces us to ask, is greatness born, or made under pressure? His decision to skip the Ivy League and attend Oregon State University proves that it's not always where you study, but how you show up. There, in a twist of fate, he met his future wife, Lori Mills, on the very first week of classes. Their bond was forged over lab reports and shared ambition, evidence that connection often emerges from shared challenge. As microchips began reshaping the world, Huang was perfectly positioned to rise. Graduating with honors, he entered the tech industry just as Silicon Valley innovation was exploding. From washing dishes at Denny's to designing the graphics processors that would power the AI revolution, his journey is a powerful reminder: our beginnings don't define us, our mindset does. As you explore Huang's next chapter, ask yourself, what overlooked struggle in your past might actually be your greatest strength? Key takeaway 2 from Paychecks to Pixel Revolutions: the moment NVIDIA was born at a Denny's. Picture this: you're a young engineer in the heart of Silicon Valley, earning just $28,700 a year, juggling a new marriage, 2 kids, and the impossible dream of launching your own company in the brutal world of hardware. That was Jensen Huang in the late 1980s. At 20, he'd already proven himself at Advanced Micro Devices, AMD, one of the most iconic chip makers of the era. But this wasn't just a job, it was the beginning of a journey that would reshape how the world experiences technology. As Huang's skill set deepened, he moved to LSI Logic, where his relentless drive stood out. It was here he crossed paths with 2 like-minded engineers, Curtis Preem, a genius circuit designer with an almost meditative connection to schematics, and Chris Malachowski, the pragmatic builder with a knack for translating vision into product. Huang became their connective tissue, the production wizard who could bridge blueprints and reality. Their chemistry was electric. As Thomas Edison once said, "Genius is 1% inspiration and 99% perspiration." Together, they had both. Their first major breakthrough came in 1989 with the Sun GX graphics processor, a chip that transformed wireframe images into pixelated 3D forms. In today's high-def world, it might seem rudimentary, but back then, it was groundbreaking. Huang's leadership earned him a top role overseeing a system-on-a-chip platform. But more importantly, that graphics chip sparked a radical idea among the trio: what if they built a cheaper version, tailored specifically for gamers? Here's the twist that changed tech history: Sun Microsystems passed on their idea. But that no became fuel for a yes that would echo across decades. Preem and Malachowski brought the proposal to Huang, quit LSI, and co-found a company together. The proposition was risky. Huang had a family to feed and knew the odds of failure were steep. Hardware startups were notorious for burning out before launch. What would you do if everything you'd worked for hinged on a decision made in a 24-hour diner? So, they did what dreamers often do: they hashed it out at a Denny's booth, scribbling plans on napkins that would eventually lead to the founding of NVIDIA, now a cornerstone of graphics processing innovation, Silicon Valley entrepreneurship, and the AI hardware revolution. Huang's story reminds us that even billion-dollar ideas can be born in ordinary places, so long as you're bold enough to believe. As you dive into what happened next, ask yourself, what vision of yours is waiting for that one fearless yes? Key takeaway 3. NVIDIA's first big bet, and the brutal setback that nearly killed it. Imagine risking everything to start a company, launching your first product to cheers, only to find out a single software update made your innovation obsolete. That's exactly what happened to Jensen Huang and his co-founders in the mid-1990s. With the video game industry exploding and heavyweights like Sun Microsystems ignoring the consumer gaming market, there was a golden opportunity in the form of graphics accelerators, plug-in cards with custom chips that brought 3D gaming to life on PCs. But where others saw chaos, Huang saw an opening. According to startup lore, some of the world's most important ideas are scribbled on diner napkins. NVIDIA's origin was no different. Huang, Preem, and Malachowski ran projections on the back of menus at their local Denny's. Huang was intrigued by the market potential but set a personal line in the sand: the business wouldn't be worth it unless it could pull in at least $50 million a year. That bar helped sharpen their strategy. They called their venture NV for New Venture, which later evolved into NVIDIA, inspired by NVIDIA, the Latin word for envy. To stand out on a sea of scrappy startups, the trio made a bold move. Their first chip, the NV1, boasted cutting-edge quadratic texture mapping, a sleek alternative to the polygon-based graphics of the time. When it hit the market in 1995, the timing seemed perfect. Blockbuster PC titles like Doom and Myst had gamers hooked. and Nvidia moved over 100,000 units, partly due to a savvy bundling deal with Virtua Fighter. For a moment, it seemed they had cracked the code. But then came the gut punch. Microsoft dropped DirectX, their new graphics standard, and it only supported triangular rendering, not Nvidia's quadratic system. In a blink, Nvidia's core tech became outdated. The launch that should have catapulted them into dominance instead left them teetering on the edge of collapse. The startup world is unforgiving, and in Silicon Valley's hardware race, there are no consolation prizes for second place. So what would you do? Abandon ship, or reboot faster than your competition can blink? This was Nvidia's make-or-break moment, and it demanded reinvention at warp speed. Huang and his team now had a choice: fade into irrelevance or double down on innovation. As you turn the page to their next chapter, ask yourself, what setback in your life could actually be setting you up for a comeback? Because sometimes the crash isn't the end, it's the momentum you need to fly. Key takeaway 4. How Nvidia rose from the ashes after a total meltdown. In 1996, the halls of Nvidia felt more like a morgue than a tech startup. Following the commercial flop of its first chip, the NV1, the company was in free fall. Staff were laid off en masse, and only a skeleton crew of 35 engineers remained. The mood? As one insider put it, funereal would be a nice way of putting it. The pressure was crushing. If they couldn't build a new graphics card, and fast, Nvidia would join the countless startups buried in Silicon Valley's graveyard. This crucible marked the world's first real glimpse into Jensen Huang's fierce leadership style. He wasn't the behind closed doors type. Huang's criticism was public, pointed, and often brutal. Even his co-founder Prem wasn't exempt. But behind that fire was focus. He made a radical call: no time for prototypes. The team would use an emulator, a code-based simulation of the chip, to build a product that might just keep the company alive. It was like building a plane mid-flight and hoping the engine started before hitting the ground. The gamble was enormous. One wrong line of code and they were done. But when the demo chip returned from the manufacturer in Taiwan, something unbelievable happened. It worked. The new card, dubbed the Riva 128, ran 3D graphics at 30 frames per second, a massive leap at the time, and gamers loved it. It flew off the shelves. Nvidia was no longer a scrappy failure, it was a rising force in the 3D gaming industry. Then came the moment that would truly catapult Nvidia. John Carmack, the genius behind Quake, needed a chip powerful enough to render revolutionary 3D worlds. He chose Nvidia. The result? The Riva TNT, the first card to crack parallel computing for real-time graphics. It introduced twin pipelines, doubling rendering power and pushing visuals to stunning new heights. Carmack called it the perfect card. Nvidia had officially leveled up, and it wasn't done. By 1998, Nvidia wasn't just surviving, it was dominating. But tucked inside the DNA of the TNT chip was something even greater. It wasn't just built for gaming, it was a precursor to something that would one day transform industries far beyond entertainment. Can a single innovation carry the seed of future revolutions? Stay tuned for the next chapter, where Nvidia's chips begin rewriting the rules of artificial intelligence. Key takeaway 5. How Nvidia accidentally built the brains of artificial intelligence. What if the same chip that powered your favorite video game could also decode the human brain? In the late 1990s, Nvidia was laser-focused on dominating the graphics card market. With a relentless release cycle, updating their GPUs every 6 months, they were crushing the competition in the PC gaming scene. But in their race to render better explosions and more lifelike environments, they unknowingly engineered something with far greater implications, a chip that could revolutionize science. The breakthrough came from Nvidia's parallel computing architecture, originally designed to handle millions of tiny calculations needed for real-time gaming graphics. But outside the gaming world, scientists were quietly chasing something far more ambitious: neural networks, artificial systems modeled after the human brain. While critics called them a dead end, a trio of researchers, David Rumelhart, Geoffrey Hinton, and Ronald Williams, revived the field in 1986 with the backpropagation algorithm. Suddenly, neural nets could learn from their mistakes, mimicking real cognitive functions. But there was one huge problem: they required immense computing power. That's where Nvidia came in. With the release of its first official GPU in 1999, the GeForce became a hit with gamers, but it was also quietly being hijacked by researchers. Gerald Tesoro at IBM had already proven a neural net could teach itself backgammon and outplay human experts. But now, With NVIDIA's powerful graphics cards, scientists had the hardware they needed to take machine learning to a new level. Think about it, a chip built for video games was now powering breakthroughs in everything from galaxy formation simulations to nuclear physics. One of the first to notice this dual-use potential was Ian Buck, a Stanford grad who co-developed Brook, a programming language that let researchers harness NVIDIA's gaming GPUs for serious science. Huang, always a visionary, brought Buck into the fold. Alongside engineer John Nichols, they developed CUDA, Compute Unified Device Architecture, in 2006. CUDA was a game-changer, a platform that turned everyday GPUs into scientific supercomputers. While CUDA didn't make money at first, Huang remained unfazed. Gamers were covering the cost, and he was fine with that. "Let the kids pay for the future," might as well have been his motto. Can a gaming company spark a scientific revolution without even trying? NVIDIA didn't just stay ahead in the GPU arms race, they opened new frontiers in artificial intelligence, all because they dared to build better tech for video games. As we look toward what's next, AI, deep learning, even quantum leaps in medicine, we see that NVIDIA wasn't just building for fun. They were quietly building the foundation of the future. Ready to discover how gaming GPUs helped give birth to ChatGPT? Don't miss the next chapter in this mind-blowing journey. Key Takeaway 6. How NVIDIA's obsession fueled the birth of GPT and the AI boom. What if the world-changing tech behind ChatGPT began with a dog photo on Twitter? While most tech giants were still dismissing GPU-based AI, Jensen Huang was playing the long game. He wasn't just betting on hardware, he was assembling a dream team of minds to transform NVIDIA from a gaming legend into a scientific juggernaut. One of his smartest hires? Bill Daley, a titan in academia, brought in to lead NVIDIA research and make it world-class. But the real spark came from a quiet coder in Toronto. 𝐓𝐡𝐢𝐧𝐤𝐢𝐧𝐿, working under Geoffrey Hinton, used NVIDIA's CUDA-powered GPUs to build a neural net that stunned the AI world, AlexNet. It wasn't just faster, it was a quantum leap in computer vision. At that moment, the machine learning revolution truly ignited, and Huang's decade of investment in CUDA finally had its vindication. Brian Catanzaro soon joined the charge, building CUDA, a deep learning library that radically sped up neural network training. Huang called it the most important project in NVIDIA's 20-year history. On his whiteboard, he scribbled a mantra, OIALO, once-in-a-lifetime opportunity. In 2014, Catanzaro demoed CUDA and lived by identifying dog breeds from Twitter in real time. It was more than just a parlor trick, it was proof. NVIDIA wasn't just enabling AI, they were now accelerating it at internet speed. Facebook, Adobe, Netflix, and quietly, Google, were watching closely. Soon, Google began gobbling up NVIDIA GPUs to power Project Mac Truck, a secret AI supercomputer built on CUDA. Wall Street finally caught up. NVIDIA's stock surged 224% in 2016, and Huang re-entered billionaire status. But for him, it was just half-time. By 2017, NVIDIA had gone full throttle, revenues doubled, profits tripled, and their chips were everywhere, powering Nobel-winning research, fueling cloud computing for Amazon and Microsoft, and even driving the crypto mining boom that added rocket fuel to their first billion-dollar profit year. Meanwhile, CUDA became the default tool for every student, lab, and startup dreaming of building the next AI revolution. One such group was Jacob Uscariot's team at Google. They built a new architecture called the Transformer, and it didn't just translate languages. It learned how language works. No human coding, no hand-holding. Just pure, statistical brilliance. Can a graphics chip unlock the deepest patterns of human expression? The Transformer didn't stop at words. It could compose music, paint, even detect artistic nuance, like a creative oracle trapped inside silicon. But the biggest twist? Google didn't fully grasp what they had. So Uscariot and others left, carrying the Transformer tech elsewhere. One of them landed at OpenAI, where that same architecture evolved into something world-shaking, GPT, the generative pre-trained transformer. NVIDIA's dream had powered the dawn of generative intelligence, and the world would never be the same. Key Takeaway 7. NVIDIA's record-breaking earnings call shocked Wall Street, but is it built to last? February 21, 2024, was NVIDIA's Judgment Day. The world wasn't just watching, it was holding its breath. Over the years, NVIDIA had grown from a gaming chip innovator into the backbone of the AI revolution. Its $7 billion acquisition of Mellanox and a $100 million deal to train GPT-4 with OpenAI were big moves. But now, the company held 90% of the AI chip market, and its processors boasted profit margins over 90%. The earnings call that day would either cement its place as a global superpower, or shake its foundations. What unfolded was historic. As the markets closed, Wall Street's ears tuned in. CFO Colette Kress dropped the bomb. NVIDIA's revenue had doubled to $60 billion, its gross margin was an astounding 70%, and its net income hit $30 billion, more than it had earned in the previous 30 years combined. It was a moment of financial storytelling few companies ever get to write. To make it more surreal, each employee at NVIDIA was now generating $1 million in profit. A tech giant had just reshaped the global earnings landscape. The market's reaction was seismic. In a single day, NVIDIA's valuation leapt by $277 billion, a gain larger than the entire market cap of Coca-Cola. With that, NVIDIA entered the rarefied realm alongside Apple and Microsoft, forming a new holy trinity of tech. Jensen Huang, once the underdog engineer who bet everything on parallel computing and gamers, was now arguably the most important man in tech. His vision had not only paid off, it had redefined the boundaries of what a chip company could become. But with such towering success comes a thin atmosphere. Who succeeds Huang? That's the question haunting Silicon Valley. NVIDIA's flat hierarchy means there's no clear heir, no second in command. Huang isn't just CEO, he is NVIDIA. That level of concentration is thrilling. And dangerous. Is NVIDIA's dominance built on silicon or on a single man's shoulders? Investors are starting to realize they're not just betting on chips, they're betting on Jensen Huang himself. And then there's the geopolitical elephant in the room, Taiwan. NVIDIA's chips depend heavily on TSMC, Taiwan's semiconductor titan, and any disruption, particularly due to rising tensions with China, could cripple production overnight. With Taiwan increasingly caught between superpowers, NVIDIA's global empire sits on a fragile fault line. The US may promise to defend Taiwan's chip plants, but promises in politics are written in pencil. In a world driven by AI, one spark could threaten the entire machine. Key takeaway 8. AI's energy crisis and NVIDIA's blind spot. Are we racing toward the edge? As AI continues to evolve at lightning speed, a sobering question looms: is any of this sustainable? The debate about AI becoming self-aware often sounds like science fiction, but there's already a very real, very physical threat: the Earth itself. NVIDIA's exponential rise has triggered a surge in global electricity demand, powering up the very data centers that fuel tools like ChatGPT, Bing AI, and Google Bard. Just a few years ago, NVIDIA's DGX machines used as much power as a clothes dryer. Today's models? They devour enough electricity to power entire homes. The environmental cost is massive, and it's climbing. Tech giants like Microsoft and Google are rapidly expanding their data centers, and so are their carbon emissions. NVIDIA's cutting-edge chips are the beating heart of this infrastructure, yet they're also the source of an energy appetite that's ballooning by the hour. Even as the world talks about sustainability, the AI boom threatens to unravel decades of climate progress. It's the hidden cost behind every headline about smarter algorithms and record-breaking profits. But the conversation gets even darker when we revisit the existential debate. Geoffrey Hinton, often referred to as the godfather of AI, has expressed serious concerns about humanity's future in the face of unchecked AI development. But Jensen Huang? He's not buying it. In an interview with journalist Stephen Witt, Huang exploded, literally yelling about the absurdity of these doomsday fears, brushing them off as childish fantasy. That didn't stop Witt from walking away deeply unsettled, convinced that Huang's corporate vision didn't account for human extinction, because it didn't matter to him. And that raises the most uncomfortable question of all: who challenges a visionary who can't be challenged? Inside NVIDIA, the leadership structure is so centralized around Huang that dissent seems unlikely. If other executives fear his volatile outbursts, can NVIDIA truly make balanced, ethically grounded decisions about a technology that might one day define, or destroy, humanity? When the volume of the server pods is so loud you can't hear yourself think, maybe no one's thinking clearly at all. So we're left in a strange place, standing on the shoulders of history's most powerful tech company, with a view that stretches all the way to utopia, or collapse. Is Jensen Huang the only one who truly sees what's coming? Or is he just the one most willing to charge ahead, regardless of what's waiting at the end of the road? In summary, The Thinking Machine by Stephen Witt tells the gripping story of Jensen Huang and NVIDIA's rise from a risky startup to a tech titan at the heart of the AI revolution. Huang's journey began humbly in Silicon Valley during the 1980s, where his relentless work ethic and unique leadership style set him apart. Together with his co-founders, he navigated early failures and industry rejections to pioneer breakthroughs in graphics processing that would later reshape computing forever. One of the book's most powerful themes is resilience. When NVIDIA's first chip, the NV1, failed spectacularly, the company was on the brink of collapse. Huang's explosive, no-nonsense leadership sparked a remarkable turnaround with the Riva 128 chip, proving that daring innovation combined with unyielding determination can defy the odds. This moment laid the foundation for NVIDIA's dominance in the gaming world and beyond. 𝐓𝐡𝐢𝐧𝐤𝐢𝐧𝐠 vividly illustrates how NVIDIA's innovations transcended gaming and became indispensable to scientific research and artificial intelligence. Huang's vision to harness GPUs for parallel computing unlocked new possibilities in machine learning, transforming NVIDIA from a graphics card maker into the backbone of the AI revolution. His unwavering belief in projects like CUDA, despite early losses, shows the power of patience and foresight in building groundbreaking technology. The book also highlights the complex interplay between innovation and ethics. While NVIDIA's technologies power incredible advancements, they also come with significant environmental and existential questions. The surge in electricity consumption by AI data centers, and Huang's dismissive stance toward fears of AI's risks, challenge readers to think critically about the future we are creating and who is accountable. 𝐓𝐡𝐢𝐧𝐤𝐢𝐧𝐠 captures the intense pressure and singular focus that define Huang's leadership. NVIDIA's success rests heavily on his vision and drive, raising questions about the sustainability of such centralized power. Yet Huang's relentless push forward has propelled NVIDIA to unprecedented heights, showing how one individual's clarity of purpose can shape entire industries and possibly our collective future. A particularly inspiring element of the thinking machine is Huang's ability to see opportunity where others see risk. From gaming chips to AI supercomputers, he consistently bet on the next big leap and wasn't afraid to disrupt his own successes. His story is a testament to the courage it takes to pioneer uncharted territories and the rewards that come with unwavering conviction. Stephen Wood's narrative goes beyond technology to explore the human side of innovation, the sacrifices, the fierce determination, and the vision required to transform an idea into reality. It's a story that encourages us to embrace challenges and maintain faith in our potential to change the world, no matter the obstacles. If you found this summary insightful and inspiring, please like, share, and subscribe to the channel to help spread this powerful story of resilience, innovation, and vision. And if no one told you lately, remember this: you are loved, you are worthy, and you are spectacularly capable of extraordinary things.